Hello and welcome to another tutorial. We are going to continue our discussion on creating objects and using them. So we saw that we use the new operator, and now if when we create the object inside a method, or maybe it's the field of another object, we get a reference or a pointer to it, right? And then what can we do with this reference? We can access the state of the created object, right? Remember, a state of the object means any object, any instance of a class holds some data, right? It has some fields that holds the data. Those fields have their own types, so we know how much the size of each field is going to be, and we can access those fields using the dot operator directly if it is allowed. So if each field of a class, we saw that, can have its own access modifiers, right? A field of type, for example, int, can be public, private, protected, or no modifier, which means package level access. So each individual field has its own access modifier rules. And then we saw that the best practice is to define every field as private, and then create public getters for any field that we want the others to be able to read from it. And we access any field, any method using the dot operator on this reference type. We saw that we cannot use a dot operator on a literal or a primitive type. Like if you have a primitive type, for example, of type int, for example, let's see if I have an example. So if you have a speed, for example, which is an int, you cannot use the dot operator on this speed. You cannot say a speed dot, right? Because it's not a class. It's not some sort of data structure or data object, right? It's just a pure data, right? It's just a primitive data. So let's go back to using objects. Once you have created an object, you probably want to use it for something. You may need to use the value of one of its fields, change one of its fields, or call one of its methods to perform an action. And all of this stuff happens via using the dot operator on the object, on the reference to that particular object. Referencing an object's fields. Object fields are accessed by their name. You must use a name that is unambiguous. You may use a simple name for a field within its own class. For example, we can add a statement within the rectangle class that prints the width and height. So system.out.println, there is a string here, plus width, plus some comma string, plus height. And what happens here, we are actually concatenating a string with a primitive, and the compiler behind the scenes create a string builder, and then adds this string to it, and then appends this integer, which will be transformed into a string and gets appended. So behind the scenes, in the recent version of Java, this line of code will get translated to a string builder, right? And this print line will be invoked on the version of the print line, the overloaded version that accepts an object. In this case, width and height are simple names, and because we are within the scope of rectangle, we don't need to say this dot width, this dot height. Some people prefer that and recommend that you always access the field of an object via the this pointer, this dot width, but Java doesn't enforce that. Other programming languages like Python always enforce that. You have to use for example, this dot something or self dot something. In Python, the convention is to use self instead of this. But so the use of self or this in Python, for example, is explicit. In other programming languages like C++ and Java, it's implicit. As long as there is no ambiguity and there is no shadowing, there is no local variable that has the same name as the field, you can directly type the name of the field and the compiler realizes what you mean, right? So the compiler is smart enough to understand this stuff, but again, some people recommend to always use this dot width, this dot height. Depends on your preference, I believe. Code that is outside the object class must use an object reference or expression followed by the dot operator. So if you have created an object, the object is initialized, so its data have been initialized and assigned. You have a reference to it, you use the dot operator, and again you say object reference dot the field name. And again, I mean, most people prefer not to do this. If somebody creates an API for other people to use, you want to make sure that all the fields are private, and then unless the field is final. For example, we saw that in the built-in array types, they have a field called length, right? The Java built-in array types, and that length is final. And in fact, the developers of the JDK actually allowed you to directly access that final field length. So you have the reference to an object of array type, you say array dot length, right? Now they could just say array dot get length or something, but they decided, okay, if a field is final, it's still okay to let people directly access it, because if they try to change the value or reassign that field to some other thing, the compiler will give them a compilation error. So final fields are still okay, but again, it's best to avoid that and then provide setters and getters. For example, the code in the create object demo class is outside the code for rectangle class. So to refer to the origin, width, and height fields within the rectangle object named rec1, the create object demo class must use the names rec1.origin. So this rec1 is the reference or a pointer to an object that we created, and we're using the dot operator to access a public field. Or maybe based on what is the access level, what access level are we allowed. So if this rec1 is created in a class which is in another package, and if this origin is, for example, not public, for example package level access, then we cannot directly access it, right? We discussed this in details when we discussed the concept of access modifiers for fields. The program uses two of these names to display the width and height of rec1, right? So width of rec1, rec1.width. So we're directly accessing the field of an object using a dot operator. Height of rec1, rec1.height. Attempting to use the simple names width and height from the code in the create the object demo class does not make sense. Those fields exist only within an object and results in a compilation error. As long as you are physically within, let's bring up, for example, this car class. As long as you are physically within the scope of the class, right, you can directly type the name of the fields in any method or any even constructor, right? So you can directly write the name, and the compiler knows that this is not a local variable. Obviously, if this method accepts a local variable, then you want to make sure that if the name is the same as the name of the field, then you want to make sure that you have the this pointer, right? This.gear. Then it means that we're not talking about this local variable, we're talking about the field, the attribute of this class. Now, some people prefer to always use this, but I personally choose not to do that because there is no ambiguity. It's very clear. And the other nice thing is the color coding. So the color coding capability of your IDE. Definitely focus on this and try to create a color code that you're comfortable with, and then stick with it. Therefore, when you open someone else's source code in your IDE, you immediately know the conventions or the coding style, right? The color coding that you're familiar with, right? For example, air, this is, I immediately know that this is a static field. It's not a method because obviously we don't have the round brackets like this. So it's a field, it's a static because it's italic, right? So Eclipse's convention is to italicize the static fields and also make them green blue, which means make them basically italic blue. So which means these are fields, right? A field is blue, the color is blue. Static fields or static variables are always italicized. Non-static fields are just regular, non-italicized, right? So this immediately tells me what's going on. This is a field, not a method, and it's a static field because it's italicized. Again, stick to your IDE, learn your IDE, know it very well, and always use that convention that you're comfortable with, right? Later, the program uses similar code to display information about rec2. Objects of the same type have their own copy of the same instance fields, right? Every instance or every object of a class gets its own data. JVM allocates a separate memory area for that particular object. For example, rec2 has a separate memory area allocated to it that is different from rec1. And then that part of the memory that is allocated to this object holds the data or a state of this particular object, right? Again, class was a footprint, which we know that every rectangle type has a state, which includes an integer for width, an integer for height. But what the actual values are going to be, they are determined when you actually create an object and call the constructor to initialize the state, right? The purpose of the constructor is to initialize the state of the particular object you're creating. Thus, each rectangle object has fields named origin, width, height. When you access an instance field through an object reference, you reference that particular object's field, right? You're accessing that particular object's state, right? You're just pointing to that object. A reference is just a pointer, points to the memory area allocated to this particular object. And we know that the memory area just holds the data or the state of the object. The two objects rect1 and rect2 in the create object demo program have different origins, widths, and height fields. That's the whole idea of having a class, which is a footprint that determines what's the attributes or the state, the fields of this particular type. And then you create multiple objects, initialize them with multiple values, with multiple states. Each object has its own copy of the state. The only exception obviously is static fields. Static fields are shared amongst all objects, and we can do a demo here. So basically, let's say let's have this cat, or maybe let's have to go to the car, for example, here. So this is a regular class. It has two private fields which are not static, but we can also have a basically a static field. So static fields are not related to a particular object. So they're not related to the state. So not related to the state. They're related to the class. They are related to the class itself. Now, most people say that class is a footprint, and then a state of the object is the actual values that the data holds, right? But that's not true. The class itself can have a state. So the class itself can have a state, and that's determined by the static fields, right? So when we say class can in fact have a state if it holds any static variables. So we can say public static. For example, we have the model for a car, plate number, right? So or a manufacturer. Public static, let's call this a string manufacturer, right? And you see Eclipse italicizes this field for me, which means that this is a static field. So if somebody uses this field somewhere else, let's say sysout manufacturer, you can still access static fields inside non-static methods. That's fine. Static fields can always be accessed. And we saw that the non-static fields cannot be accessed inside static methods just because non-static fields are associated with the state of a particular object, but static methods are not associated with the particular object. Now, as you can see, as soon as I see this line of code and the fact that Eclipse makes this variable blue, first of all, it tells me it's a field because it's colored blue, right? Every variable that is a field of a class is blue. And then Eclipse italicizes this, which immediately tells me this is a static field, right? And obviously, if I hover, it quickly shows me the green dot. Green with the white dot means it's a field which is public and it's also static. So even hovering your mouse over a variable in the IDE helps a lot to tells you this is a public and this is a static, and obviously it's a field, it's not a method because it has a white dot inside the green circle, right? A white dot. If I have a public method that doesn't have a white dot, right? If I hover over something that doesn't have a dot, means it's a method, right? But if it has a white dot in it, it means it's a field. Okay. So again, a static fields. Now with the static fields, let's create class a static field demo. Let's have a main method. Now a static field a static field determines or fields determine the state of the class. And note that what this means is that every instance or object of the class shares the same state of the class. So let's say we say, first of all, the way you access static fields directly through the name of the class. That's the convention. So we say car, right, dot manufacturer. And as you can see, Manufacturer is a public static field that is available to us. We can directly access it and set it to Tesla, for example. All right, so we directly assign this. Okay, so I think there is a type mismatch here. Did we import a string? Yes. So because we defined our own string type, and I guess this string was first. So we have to use a fully qualified name, Java lang string, to differentiate this type string from this type, which is in another package. So if you're not familiar with what the fully qualified name is, definitely go and review my past lectures on it. In general, you are supposed to always type fully qualified name. Whenever we say type, it means fully qualified name. That's the JVM understands. But it gets tedious if we have lots of packages inside other packages, or if we have a deep package hierarchy. So they allowed for the import statement. The limitation is that you cannot import two different types with the same name but different package hierarchy. So the limitation is that you can only import one of them. So if I have a class called a string, but there are two different types of a string, one is inside this package that I defined, one is inside Java lang. So I can only import one of them. So every time I type a string by itself, it refers to the imported one. And for the other classes that are the same name as string, I have to use the fully qualified name. Now this assignment works, and I can even access, so this is the write operation to a static field, write operation to the state of the class. Note that we haven't even created an instance of this, an object of this type car, but we are mutating its state, the class state, to the state of the class via the static field. So car.manufacturer, and this is going to print us the Tesla, right? Yes. And now let's go ahead and create two cars, right? Car 1, car 2. For car 1, we're going to create a model 3, and for car 2, we're going to create a Tesla model Y. All right, so car model 3 is a new car. Remember, new operator, and autocomplete shows us what public constructors are available, and the price. We're going to set the price for model 3 in 2021. I believe it's about 50,000. So 50. And remember, we saw that when we discussed integer literage, we saw that you can use underscore for literage. So $50,000. Let's say new Tesla Model 3 price in 2021, for example, or 2022. So what about Model Y? Let's create a Model Y, car Model Y, and know that I'm using the camel case notation. So the first word is lowercase, the second word, which just Y, it's uppercase. And let's start with 70 or 60, for example. So let's say new Tesla Model Y price in 2021 was about $60,000, right? US dollars. Now, if I do a sysout on the Model 3 manufacturer, now this works. It's a static field, but and I can print it. So let's see. Yes, we are reading this static field, but you see, I get a compiler warning. And what is this warning about? It tells me that the static field car manufacturer should be accessed in a static way, but it's not a compiler error, right? So it's a warning, and the warning is just telling us, okay, I didn't copy the warning. The warning is telling us, hey, the convention or the best practice is to always access a static field via the name of the type instead of an instance, because this a static field is not associated with the state of the object. The state of the object is the state of the class is part of the state of the object, but it's the class itself. You basically, the best practice is say car.manufacturer, then you don't get a compiler warning. But again, this works fine and your code compiles, so it gives you the result that you expect to see. It's just not the best practice, because you want to always separate the state of the class via the static fields and the state of the object via the non-static fields, right? Now the key here is that every particular class, every object can modify modify the state of the class. So model3.manufacturer, we can say Tesla of I don't know, USA. I guess Tesla is also creating manufacturing sites in Germany, or China or somewhere else. I'm not sure, but again, it tells me that, hey, why are you accessing this via the static field, via the object instead of the class itself, even if you're assigning? But this is allowed. The thing here is that if now this model 3 changes the manufacturer, model y immediately sees this change. So model y dot manufacturer, as you can see, now this is not going to be Tesla, it's going to be Tesla of USA. Yes, yeah. So if one instance on one object of a class changes the state of the class, which means it changes some of the static fields, other instances immediately see them. And later on, when we discuss more about the details of Java heap and internals of the JVM, you will see that that's because there is a special area of the memory for static fields that is shared between all the objects, right? This variable is actually not part of the memory that is allocated for when you call this new operator. This variable is stored in a separate area of memory, completely unrelated to the memory area that was allocated for the state of this object. Whenever you call the new operator, JVM allocates memory in the Java heap and then initializes the values, right? Puts the values of the fields in those memory area. But static fields are not stored in that area that is memory area that is allocated for the state of the object. So these are allocated separately somewhere else, and there is only a unique copy of this variable among all the basically objects. Even if I put this right at the beginning, as soon as somebody changes the static field or the state of the car class, this model y will see it. So if we come here and then we look at the manufacturer for model y is still going to be Tesla of USA. Yes. So again, these variables, static fields, are stored someplace else, independent of the memory that is allocated for the state of the object. And then everybody can change that. Every object, it's not recommended to access static fields via the object references. You should always use the class reference, the name of the type, basically. That makes code clear that, hey, this was a static field, right? All right, so to access a field, you use dot operator. You can create an object in place, new rectangle, and access the field. The downside, we saw that this creates a temporary reference, right? And then as soon as you get the height and then go to the next line, you lose access to the state of this object because you didn't store a reference or a pointer to this object, right? So if you want to just create temporary, you can do this. And if you want to retain access to the memory area or the state of this object, you have to assign the value that new operator returns to some pointer or reference type. This statement creates a new rectangle object and immediately gets its height. And I like to call this a temporary object or in place object. In essence, the statement calculates the default height of rectangle. Note that after this statement has been executed, the program no longer has a reference to the created object. So it's completely lost, and the memory area for the state is garbage now, and it can be collected and the memory can be recycled for other objects because the program never stored the reference anywhere. The object is unreferenced and its resources, which means memory that it was occupying, are free to be recycled by the Java virtual machine. So I hope you enjoyed this lecture. Please stay tuned and I'll see you in the next one.